Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Uh, I just noticed that your test for the AP Calculus AB is like in 5 days. So, and I won't be available over the weekend. So I just try to cram like a back exam for you. I said I'm going to start with the free, like the free response questions. You know, that's section 2. There are two parts, one with a calculator and one without. I'm planning to do the part with the calculator today. And if we have time, maybe I'll pick another problem from the non-calculator portion and then complete it tomorrow. And then by Friday, I'll try to do as many multiple choice questions as I can. Wish you all the best in your test. I'm sorry I didn't realize it's coming that soon. So that we don't waste time, let me start with the computer part. There are two problems, as you know. It's 30-minute test. In the first one, it says water is dripping from a pipe into a container whose volume increases at a rate of, and then they didn't write what rate, like you guess. No, I went online and checked, and it turned out to be it's 150 cubic centimeter per minute. The water takes the shape of a cone with both its radius and height changing with time. Of course, they change as the water increases. So it's not like a cylinder where the radius is constant and only the height changes. No, now both change. So it tells you, okay, so let me get a piece of paper. Question number 1, part A. So first of all, dV dt, the volume changing in time is 150 cubic centimeter per minute. Oh my God, the pen. This is a new one it has. Why it's getting like it's ending? Oh, anyway. What is the rate of change of the radius of water, meaning the RDT? That's a related rate problem right there, as you can see. What is the RDT? At the instant when the height is 2 centimeter and the radius is 5 centimeter. At this instant, the height is changing, so dH dt at a rate of 0.5 centimeter per minute. And we want the RDT. Like, you need to write the volume in terms of the radius and the height. So you would say, I know the volume of a cone is 1/3 pi r square h, right? The area of the base times the height. 1/3 the area of the base times the height. And now you take the derivative of both sides with respect to time, noticing that both r and h this time change. So are functions of time, and they are multiplied, so we have to apply the product rule. So I'm going to say dV dt equals pi over 3 is a constant, so I can factor it out and then say, okay, the first times the derivative of the second plus the second times the derivative of the first, r squared, its derivative is 2r dr dt. And then you just substitute. So you say dV dt is 150. Without that, we couldn't solve, of course. Pi over 3. R squared is 25. dH dt is 1/2, so 25 times 1/2 is 25 halves. Plus 2 times 2 times 5, just to save time instead of writing that, it's 20 dr dt. Now, in order to solve for dr dt, we need to multiply both sides by 3 over pi. So you get 450 over pi equals 25 halves plus 20 dr dt. Then you subtract 25 halves from both sides. These would cancel. And finally, divide by 20 both sides. So you get dr dt. And then you use your calculator. The numerator here is 450 divided by pi minus 25 halves divided by 20. Everything divided by 20, right? So you get this is 6.537 centimeter per minute. That's part A. Pretty straightforward, right? Part B, there are B and C and B, or B, C, D, oh, B and C. So in part B, it says the water begins to be extracted from the container, meaning a negative. Here, water is dripping, so it's increasing the volume. Now we are going to extract water. So we can say E of T is, I would write it negative since it's going extracted 75 T to the 1/4. Okay, water continues to drip from the pipe. So I still have the 150 minus that. So basically, dV dt would be 150 minus 75 T to the 1/4. And they tell you, when is the water at its maximum volume? I know that if I have a function, V, and I want to find the maximum, I would take dV dt, which is already, we already took that, and we equate it to 0, right? And then check, is that a maximum or a minimum by taking the second derivative? If I get negative, meaning the concave down, so I reach a maximum and then drop. If it's a concave up, I will get a positive second derivative, because they tell you justify your reasoning. That's why you have to check. So first of all, you equate that to 0. So you add 75 T to the 1/4 to both sides. I'm going to move this to the left and this to the right. So I will get 75 T to the 1/4 equals 150. Then I'm going to divide by 75. I get T to the 1/4 equals 2. And then I'm going to raise both sides to the 4th power, right? So I can cancel this and I get T equals 2 to the 4 or 16 minutes. It will take 16 minutes to reach the maximum. That's not the end of it. I have to take d2v by dt squared, second derivative. Derivative of 150 is 0. I have a negative 75. And then derivative of t to the 1/4. The 1/4 would be a multiplying, meaning it will become negative 75 over 4 times t to the negative 3/4. Or I can write it as 1 over, you don't have to, but you can write it like that. Now, all of these values are positive. 75, a 4, a t to the power cannot be negative. So, but there is a negative sign in front of it. I don't have to evaluate anything because I don't know how to evaluate it, but I know it's negative. Hence, max. That's the justification. Now, the last part, which is part C, it says by the time water began to be extracted, there was 3,000 cubic centimeter of water already leaked from the pipe. So the tank contains 3,000 cubic centimeter. Right, but do not evaluate an expression with an integral that gives the volume of water in the container at the time in part B. What's the meaning in the time of part B? Oh, meaning when it began, water began to be extracted. Don't evaluate. So why would I do that? I don't know. Anyway, the volume, we know the volume is already 3,000 is inside. But then I will integrate this part because that's dV dt. So plus integral of 150 minus 75 t to the quarter dt. Just that? I don't know, this is weird. I don't get it, but that's basically what they want, right? Yeah, just write it and don't evaluate. So the 3000 is the volume and this is dv dt, so you integrate it with respect to t. Okay, whatever. Now we move to the second problem. It's what, 10 minutes? Okay, so we are going good. I think we'll take a problem from the second part then. Number 2. The temperature in a room increases at a rate of dt. The capital T here is temperature in Fahrenheit. And T, of course, is a time in hours. Equals KT. So we know that this is an exponential, it's a differential equation and its solution is differential, exponential. Part A, it says find the equation for T in terms of T. So T as a function of T. Okay, uppercase T in terms of lowercase t, but they have to give you some conditions. So they tell you the temperature. Okay, so initial condition at T equals 0, capital T was 65 degrees Fahrenheit. That's not enough because I don't know K. And then when I integrate, I will get a constant. So I need 2 equations or 2 conditions. So they tell you it's 70 after 1 hour. So when T is 1, because T is in hours, so 1, not 60, for example, capital T is 70 degrees Fahrenheit. So to solve this, we use separation of variables. Of course, I'm going to say dt over t equals k dt. And then we'll integrate both sides, right? The integral of the left-hand side is natural log of t. I'm going to use absolute value, even though the t here in Fahrenheit, unless they ask us for a negative temperature, is positive. I don't need the absolute value, but it doesn't harm. Equals kt plus a constant. Okay, so if I want to solve, I would exponentiate both sides, right? I would say, if I raise e to this power equals e to that power. E is the inverse of natural log, so they cancel each other. So the left-hand side is t equals e to the kt plus a constant. Well, I can separate that and I say e to the c times e to the kt. But e is a constant, c is a constant, so why do I write it as an exponential? I can write it, for example, c1 times e to the kt. And now I need to know c1, I need to know t. So I know that t is 0, capital T is 65. So 65 equals c1 e to the 0. But e to the 0 is 1. So I found the constant c1 equals 65 degrees Fahrenheit. Then I would say when t is 1, 70 equals the 65 that I already found, e to the k times 1, so e to the k, which means e to the k equals 70 over 65, or 14 over 13 if you wish. I'm going to take the natural log of both sides. I should have left the space here. These cancel, and I get k equals natural log of 70 over 65. It's 0.0741. So I'm done. I can write t equals 65 e to the 0.0741 t. That's part A. Okay, now we move to part B. It says, how many hours will it take for the temperature to reach 85? Of course, that's a child play. 85 equals 65 e to the 0.0741 t. I'm going to divide both sides by 65. Again, I can simplify that as 17 over 13, but then I will take the natural log. So the natural log and the e cancel each other, and I will get 0.0741t equals natural log of 85 over 65. Then I will divide both sides by 0.0741, 0.0741, and I get t equals natural log of 85 over 65 divided by this constant. Oh, why did I have, I'm sorry, I opened two parentheses. Yeah, the natural log opens one, so I think it included everything over 3.62 hours. Let me check which one is the correct. Let me see what. Yeah, this would include, okay, so that was wrong. I didn't notice that the natural log opens a parenthesis, so I opened another one. So be careful, don't do it like me. Okay. What about part C? The last part says, after the temperature reaches 85, meaning after 3 hours and 62.62, meaning roughly, what, 37 minutes, a fan is turned on and cools the room at a consistent rate, meaning constant rate of 7 degrees Fahrenheit per hour. So now my original equation or differential equation, instead of being kT, K is constant, of course, because that's the cooling constant, minus 7. And then I have to resolve. They tell you how long will it take for the room to reach 0 Fahrenheit. So T equals what for T equals 0? Notice here I have to resolve the problem. I want to separate. And some students will say, how do I separate? There is a constant. So what do I do? A very simple trick, it's not a trick really, is that I know that I want to separate the T, but I cannot. Because if I move the 7, I divide by K. So it's like, it doesn't work. So the trick is to multiply by K and divide by K. I didn't change anything, right? Then factor the K out. So that would give me T minus 7 over K. And now I can divide both sides by T minus 7K. So I get dt over T minus 7 over K equals KT again. And then I'm going to integrate like I did before. I know the K, so the K is, I'm not going to write 0.0741 many times, so I leave it as K, but I will evaluate it as 0.0741, which we already found. Okay, so the left-hand side, it's the natural log of T minus 7 over K, right? 7 over K is a constant, so when you integrate, you get that. Equals KT plus a new constant, so I'm going to call it, notice this was capital C1, this is a lower, well, call it C2, so it's not the same constant. Then I'm going to exponentiate like I did before. So I get T minus 7 over K equals E to the C2 times E to the KT equals, say, C3 E to the KT. Now I need to find C3. What do I do? At T equals 0, it's not really 0. It's after we reach 85. So at T equals 362, I don't care about that, but this T becomes 0 because I said, after it reached 85, I started the fan. So now I'm calculating a new time. This is my time 0, right? This is 85 minus 7 over 0.07, whatever, equals C3 e to the kt, but now t equals 0, so that is 1, so this is C3. So now my new equation is t equals, okay, or t minus 7 over k if you want. T minus 7 over k equals 85 minus 7 over k times e to the kt. Now I want t to be 0. So I would say at t equals 0, the left-hand side would be negative 7 over k. The right-hand side is 85 minus 7 over k, e to the kt. So in order to solve for t, first of all, I will divide. So maybe we get a new paper so it won't be confusing to you. At t equals 0, I have to divide both sides, so I get negative 7 over k divided by 85 minus 7 over k equals e to the kt, right? If I divide both sides by 85 minus 7 over k, 85 minus 7 over k, these cancel, and you get e to the kt. Then, like I did many times now, I'm going to take the natural log. So the left-hand side would be kt equals natural log. I hope, you know, if someone watching the video is called Katie, she understands we are not making fun of your name, okay? KT here is not. Okay, just kidding. Just trying to let you relax before the exam. Okay. Natural log of negative 7 over k over 85 minus 7k. And then I'm going to divide both sides by k to calculate t. So t equals, now we have to be careful when we do the calculator. I have natural log, which opens a parenthesis. So this time I'm not going to open a parenthesis. Negative 7. No, this time I will. Why? Because the numerator is negative 7 over k, close the parentheses, over, and then I open a new parenthesis, 85 minus 7 over k, close, close, and then I divide by k. I hope I did it correctly. That's too many. 31.05 hours. And this is the first part of the test, 23 minutes or 24, that's good. So we have time to start the second part, which is problem 3. So let's look at problem 3. Problem 3, it says, let R be the region enclosed by the graphs of y equals 2 over x plus 1, y equals x squared, and the lines x equals 0, the y-axis, and x equals 1. Okay, so it's better to just graph it quickly. And this part is with no calculator. Okay, so I know it's from 0 to 1, so we are in the first quadrant. Okay, so to plot 2 over x plus 1, I know how to plot 1 over x. X plus 1 would be left one, and then I dilated y by factor of 2. It doesn't matter because really all what I want is this region. Excuse me. At x equals 0, y equals 2 for the first graph. So let's call it f of x. And this is g of x, for example, instead of y. So 0 and 2 is a point. And then at x equals 1, you get 2 over 2, which is 1, so 1 and 1. And this thing looks something like that. This is 2 over x plus 1. Y equals x squared. We know that it's a parabola going like that, and it's opening on, I don't need the left-hand side, and this is y equals x squared. And this region is R. So they tell you, part A, find the area of R. Very easy. I'm going to take a small strip of width dx. So now, if this width is dx, I have a rectangle whose height is this function minus that function, right? So I'm going to integrate. So area equals the integral, x going from 0 to 1. The top, which is 2 over x plus 1, minus the bottom, which is x squared dx. Right? So when I integrate that, I get 2, the natural log of x plus 1. Well, I don't need the absolute value because x goes from 0 to 1. So x plus 1 would be from 1 to 2 anyway. So I can say, I mean, it's not wrong to say, to write the absolute value, minus x cubed over 3. How can I evaluate that without a calculator? Doesn't matter. We are going to just leave the natural log, going from 0 to 1. So it equals, in the first part, I substitute x is 1, so you get 2 natural log of 2 minus 1/3. Minus, when you substitute 0, you get 2 natural log of 1, but natural log of 1 is 0. Minus 0 over 3. So really the second part is 0. So the answer is 2 natural log of 2 minus 1/3. Unless you know that the natural log of 2 is what? 0.693 roughly. So you can multiply that by 2 and do the math manually. I'm just kidding because it doesn't make sense. Why would they put this problem in the no calculator portion? That was a practice test, not an actual test. So maybe they didn't realize that it's no calculator without the use of any calculator. Okay, part B, find the volume of the solid generated when R is revolved about the x-axis. So I'm gonna revolve this around the x-axis. Do you see what shape will happen? I will get a washer, right? So I will get something that looks like that. The outer is the 2 over x plus 1, and the inner is the x squared. So really, to find the volume, I would say the volume equals, again, the integral from 0 to 1. The dx here is the thickness of that washer. So I will have dx at the end anyway. But what do you get? Pi r square will give me the outside minus pi r square. So if this is r1, which is which is x squared, and this is r2, which is 2 over x plus 1, I will get pi. And then this guy would be 4 over x plus 1 square minus x square is x to the 4. Right? I square that. So pi r square minus pi r square. So let's integrate that. Pi times. This is x plus 1 square, or x plus 1 to the negative 2. You raise the power 1, you get x plus 1 over negative 1, meaning without the square, divided by negative 1. So this becomes negative 4 over x plus 1, right? Minus x to the 5th And these are going from 0 to 1. So the volume equals pi times. When I substitute 1, I get -2, 4 over 1 plus 1. Minus 1, because if x is 1, then x to the fifth is 1. Minus. When x is 0, I get 4 over 0 plus 1 is 4 over 1, so I get -4 minus 0. Oh, I'm sorry, over 5. Why didn't I say over 5? Oh my God. I don't know how to integrate x to the 4dx. All righty. So I have negative times negative is positive. 4 minus 2 is positive 2. 2 is 10/5. So minus 1/5 is 9/5. So I get 9 pi over 5. Here I have to say square units because they didn't give me any units. And this is cubic units. 9 over 5 is 1.8. So you can write it 1.8 pi. And again, if you, I know all of you know like 100 digits for pi, just multiply it manually and get the answers. You don't have a calculator. I really don't know what they are doing. Alrighty, so, oh, no, we still have a part C. Set up but do not evaluate the expression for the volume of the solid generated when R is revolved around the line x equals 2. So if I have x equals 2 here, I want to revolve this area around it. Okay. So now I will have a cylinder, right? If this rotates, let's see what we have. First of all, this distance is not x, it's 2 minus x, right? Because this is x. So I will have the integral from 0 to 1, and I will have 2 minus x. And then what do I have? The top minus the bottom also would give me this height times dx. So now I have this area. When I rotate it about the 2 minus x, it will generate like a cylinder. And this cylinder, I will take strips and rotate them. So that becomes 2 pi times r, which is 2 over x plus 1 minus x squared dx, something like that. And that would be, they tell you don't evaluate it. Of course, that would be very tough to evaluate, especially that you don't have a calculator, so you cannot plug it in. And basically, that's the first part for today. In fact, it's late at night, but maybe I will do the rest, like problems 4, 5, 6, and then probably post them tomorrow. I'll see. So this would be Wednesday. The next one would be Thursday. And then on Friday, I'll do the multiple choice. Okay. Again, if you have any questions, please, we don't have time. So if you have a specific question, you can ask me. I will go over this again. If I find some error, I will make a corrections quickly with a short video, just because time is really of essence here. Otherwise, I wish you all the best in your test and hope to see you soon.